Chapter 10, Exercise 14, is very similar to Chapter 10, Exercise 13, except now we're trying to balance an equation that isn't given to us. So the first thing we have to do is to take an acid and a base that's given to us, write out the whole equation, and then balance it. So the previous question was asking you just to balance it. Now we have to figure out what the products are and balance it after writing those in. Remember what a neutralization reaction is. It's a reaction where an acid combines with a base to give you a salt and water. And that formula is helpful when you're trying to predict what the products of these are. The H and the OH combine to give you HOH or H2O. So you can see how the H and the OH would give you H2O. So hopefully it makes sense how an acid could combine with a base to give you water all of the time. Okay, now that leaves the other stuff to create the salt. And to find out how the salt will combine, you want to write each of the ions separately. So SO4 is a polyatomic ion. And you would know that because when you look at this compound, you have more than 2 capital letters. That's a sign that you have a polyatomic ion. Remember that there are 3 polyatomic ions that you would be expected to memorize. The first one is OH-, and that's called hydroxide. The second is CO3, 2-, and that one is carbonate. And the third one is PO4, 3-, and that is called phosphate. If you're ever given a polyatomic ion that is not one of those 3 on an exam, then the charge on it would be given to you. So for example, it would be given to you that SO4 has a 2- charge on the exam, because this is not one of the 3 polyatomic ions that you would want to have memorized. Okay, sodium. Sodium is in group 1A on the periodic table, so it has a +1 charge. Always take the positive ion and put that first in the compound. The negative ion always comes second. And then you crisscross the charges. The 2 at the top right of sulfate will become a 2 at the bottom right of sodium. And the 1 at the top right of sodium will become a 1 at the bottom right of sulfate. Except that by writing sulfate, you know that you have one of them. And so it would be redundant to write a 1 down here. That is implied by the sulfate being there. Okay, so this is our equation, and now we just have to balance this. Remember, when you're balancing these neutralization reactions, balance everything that is not oxygen or hydrogen first. Also, if you have a polyatomic ion, remember to treat that as one thing. So here, our polyatomic ion is sulfate, SO4. The 4 is part of that ion. That's all clumping together and acting as one thing. So we're going to treat that as just a giant green blob. How many giant green blobs do I have on the left? Just 1. The 4 is part of the blob. There are no numbers outside of that. So just 1. How many green blobs do I have on the right? And if I look at the bottom right, I see that there is no number there, so it's just 1. So the sulfates, the green blobs, are balanced. Now let's think about the other element that is not oxygen or hydrogen. Sodium. On the left, we just have 1 sodium. Nothing is written at the bottom right of the sodium, and so there's an implied 1. On the right, we have 2 sodiums. So what do we need to multiply the smaller number 1 by to give us the larger number 2? 2. 1 times 2 is 2. So now the sodiums should be balanced. Okay. After you balance the elements that are not oxygen or hydrogen, balance the oxygens. because the oxygen on the left is only in one place, whereas the hydrogens on the left are in two, so they would be harder to balance. So how many oxygens do we have on the left? Now I'm not going to consider the oxygens that are in the polyatomic ion. I already balanced those. I already took those into account. And they're not oxygens, they are clumped into something acting as just one thing, sulfate. So I'm only going to look outside of the polyatomic ion. On the left, that means that I have oxygen in NaOH. There's only one oxygen in each NaOH. But remember that we have two NaOHs, so you would distribute that 2, and you would have 2 oxygens on the left. On the right of this arrow, I'm not going to look at the polyatomic ion, I've already balanced that. So I'm just going to look at water. How many oxygens do I have in this water? Look at the bottom right of the oxygen, and there's only 1. What do I need to multiply the smaller number 1 by to give me the bigger number 2? 2. 1 times 2 is 2. That would give me 2 oxygens, and the oxygens would be balanced. Now, if you've balanced everything that's not oxygen or hydrogen, and you've balanced the oxygen, the whole equation should be balanced. So let's just go through and make sure. Let's see if the hydrogens are balanced. And we'll go one compound at a time. In this first compound, we have 2 hydrogens. In the second compound, remember to distribute. There are 2 hydrogens. 1 hydrogen in each compound, distribute the 2, 2 times 1, so 2. That means total on the left side we have 4 hydrogens. On the right side, there are no hydrogens here, and remember to distribute the 2. 2 hydrogens in each compound, 2 compounds, so 2 times 2 is 4. The number of hydrogens are equal on both sides. The hydrogens are balanced. Okay, next, let's see about the sulfates. We have 1 sulfate on the left, that's the green blob. We have 1 sulfate on the right, green blob, so those are balanced. Next, sodium. We have 2 sodiums on the left. We have 2 sodiums on the right, so those are balanced. And last but not least, the oxygens. I'm not going to count the oxygens in the sulfates because those are already balanced. We balance those when we balance the sulfates. So I'm just going to look outside of that. And here, I have oxygen in NaOH, sodium hydroxide. Remember to distribute the 2, so I have 2 oxygens here. Remember to distribute the 2, so I have 2 oxygens here, and the oxygens are balanced. So you can see that each element, each ion here is balanced, and the overall balanced neutralization reaction between sulfuric acid and sodium hydroxide is this. For B, I would request you to see a separate video that I'm going to post on our Kaltura channel. So there's going to be a separate video for B. So let's try to do C. Same procedure. They give us the acid and the base, and we know that it's going to give us a salt, and water. And if you just wanted to see that a little more clearly, you could see that the H combines with the OH to give you HOH, which is really just H2O. So that's the water. Now for the salt. To figure out the salt, you want to write the ions for everything that's not hydrogen or oxygen. So for example, this CO3, that's carbonate, it's a polyatomic ion, and you would know that because when you looked at this compound, there's more than 2 capital letters. Whenever you have more than 2 capital letters, you have a polyatomic ion, and you'd want to especially know these 3 polyatomic ions. You would want to have those memorized for an exam. So CO3 2- is carbonate. So we would know the charge on this because we have memorized that polyatomic ion. Next, magnesium. Magnesium here is in group 2A on the periodic table, and that means it has a 2+ charge. Now, we can take these two ions, always put the positive one in front, and because the charges on these are the same, they combine in a 1-to-1 ratio. It only takes one of each for the total compound to have a zero charge and to stop being sticky. So the compound here will just be MgCO3. If the charges on each thing are ever the same amount, just write the compounds next to each other without their charges. Okay, so that is our equation. Now we just have to balance it. Let's balance everything that is not hydrogen or oxygen first. Then we'll balance oxygen and hydrogen last. So keep in mind that carbonate here is a polyatomic ion, so we're going to treat that whole thing as just one thing. How many carbonates do we have on the left? Just one. The 3 is part of the carbonate. How many carbonates do you have on the right? Just one. Again, the 3 is part of the carbonate. It's not the number of carbonates. If you're curious what it would look like if you had more than one polyatomic ion, that would be something like if you had, let's say, for example, this. So notice how this is the polyatomic ion, but there's a number outside of it. So that's what it would look like if you had more than one. Here we only have one on each side, and so it's balanced. Next, the other element we have that is not oxygen or hydrogen is magnesium. How many magnesiums on the left? Just one. How many on the right? Just one. So the magnesiums are balanced. Okay, now let's look at the oxygens and balance those. Now I'm not going to pay attention to the oxygens in the carbonates because we've already balanced those when we balanced the carbonates. So only oxygen here. Now each OH has just one oxygen in it, but we have two OHs, so you distribute the number outside of the parentheses to each of the things inside. That means that we have two oxygens on the left. How many oxygens do we have on the right side of the arrow? Now, I'm not going to pay attention to the carbonate, like I said, so in this water we only have one oxygen. No number is written at the bottom right, so there's an implied 1. So what do I need to multiply the smaller number by? 1, to give us the larger number, 2. 2. 1 times 2 will be 2. And so now we would have 2 oxygens after distributing, and the number of oxygens would be balanced. Now at this point, if you're pressed for time, if you've balanced everything that's not oxygen or hydrogen, and you've balanced the oxygens, the whole thing should be balanced. But just to make sure, let's go through and check our work. Let's balance the see if the hydrogens are balanced first. On the left side, we have hydrogen in 2 different compounds. Let's look at that separately. In the first one, we have 2 hydrogens. In the second one, we have 1 hydrogen inside the parenthesis, but we have 2 of each of everything inside the parenthesis. So we distribute, and that means we have 2 hydrogens on the left side coming from that compound. Altogether, we would have 4. On the right side, hydrogen is only coming from the water. Remember to distribute the number in front. 2 hydrogens in each water, and we have 2 waters. 2 times 2 is 4. The number of hydrogens are equal on both sides, and so the hydrogens are balanced. Okay, next. So that's the hydrogens. Carbonates. 1 carbonate on the left, 1 carbonate on the right, so those are balanced. Magnesiums. 1 magnesium on the left, 1 magnesium on the right, so those are balanced. Last but not least, oxygen. I'm not going to count the oxygens in the carbonates. I balanced those when I balanced carbonate. So I'm just going to look outside. There's 1 oxygen in each OH, but we have 2 OHs. So that means we have 2 oxygens outside of the carbonate on the left. Again, I'm not going to pay attention to the carbonate because I already balanced that. So on the right, the other oxygens are only coming from water. There's 1 oxygen in each water, but we have 2 waters. So when you distribute, you have 2, and the oxygens are balanced. So all of the elements are balanced, and this would be the overall balanced equation for the neutralization reaction that happens between carbonic acid, which forms when water combines with carbon dioxide, and magnesium hydroxide, a common base is administered to treat to treat heartburn. So in this problem, you saw how you can use the general outline for a neutralization reaction to complete the reaction between an acid and a base. And then we saw how the procedure for balancing that reaction that we developed in the last problem can fill in and balance the reactions that we came up with.